Hi, my name is Jason Kreidner. Yeah, sorry to bust your ears out there. It's actually kind of good to be loud because I know it's a really loud, noisy environment. So I'm a co-founder of BeagleBoard.org, and I'm going to jump right into some tricks here pretty quick. But I do want you to have some idea what a BeagleBoard is and what a BeagleBone Black in particular is. So this is the BeagleBone Black, right? So this is the newest BeagleBoard. It's $45 in the Maker Shed, and it's a gigahertz computer. But one of the really neat things about it is it's running it runs Linux. It's a full-on Linux distro, and you can plug in keyboard, monitor, and mouse, and use it like a desktop computer. But the cool thing is it's a computer that connects up to the web and the internet and then actually connects up to the real physical world, right? So there's analog to digital converters on here, there's pulse width modulators, and that's all a lot of fancy talk for it talks to things, right? The things that the real world talks to, right? So just about everything in the world can be provide some analog value, right? There's some sort of sensor out there, whether it's air pressure or temperature or heat, well, that's the same thing. If it's carbon dioxide, there's some sort of sensor that turns that into an electrical value. And an analog to digital converter lets you take that electrical value and make it something that you can do fun things on a computer. And this has analog to digital converters built into it. So if what you've done is you've done some fun projects with an Arduino and now you want to make it talk to the rest of the world, do some fun web stuff with it, then that's exactly what we're going to do. So this is still a BeagleBone Black here, but I've just got some other stuff wrapped around it because I wanted a potentiometer on here. So this is just something that gives me an analog value, right? So this could represent light, heat, carbon dioxide. It could represent all sorts of things, and I'm just going to use that as a proxy for my sensor. Right, but I could wire up all sorts of other sensors to it. So when we start looking at what this other stuff is, just realize that this thing here really could be telling me any type of data, all sorts of types of data. And I didn't have to really, so I've got some nice, fancy board plugged in here on top of it. I could just be wiring up stuff, right? So I just did that because it's easier for me to carry around in my backpack. Right. Same with the laser cut box and the battery. So this is all just for my convenience. And I'm gonna actually just jump in and show you the demos first, and then we're gonna start tearing it down and look at how I actually made these things. So I've got 5 quick little demos I'm gonna show you. They're all really simple. And is it cut off on the screen out there? If it's not cut off for them, it's fine. I know what it's. That's what you see?
Actually, it's not cut off. Very good.
It's not cut off? Okay, if it's not cut off for you guys, then we're good. So if you see here, this is a web page that's being served up by the BeagleBone. And this USB cable is acting as my network connection. So it's also providing power to the board, and that's just a really convenient thing because this is the way you can get started with it out of the box. So if you buy the board, you get the cable, that's what's in the box. The software is already preloaded on it, so you don't have to do a lot there. And you can start developing these fun little web pages that are interacting with the real world. So this is just a really simple web page, and here again, I'm just reading an analog value, and it's changing dynamically on the screen there. You see that number goes all the way from 0 all the way down to 1, right? So, and you see it changing really fast. I can move it really quick, and it keeps up with me, right? And that's using a thing called a jQuery. But just again, so the web server here is running on the board, and it ships with that web server, and it ships all the tools you need to actually develop things with that web server. If I were to take this off of the USB and hook it up to an Ethernet, or to put a Wi-Fi dongle on here, I could put this out anywhere I wanted, and then I could use the battery to run that off there. But here I was actually going to originally try to hook it up over my cell phone and out on the internet, but as everybody's seen, the internet connections here are really lousy, so I just dumped that plan. So we're just using a nice solid cable. So that's demo number 1. The next one I'm going to show you is there's some just really fantastic tools. I can show you one there where you can just update content on a web page really dynamically. And these are all just open source tools you can pull off the web. Here's another one that's jQuery's Flot. And so not a lot of magic going on here, right? So, but if I push the slider down, it goes to a 1, goes to 0, right? And you can see it's very, very responsive to me. And I'm not doing a whole lot of magic. It ships with a JavaScript library that I can embed into any web page. And it communicates with the ADD converters on the board. It also communicates with the digital signals. It communicates with the pulse width modulators and other things if I wanted to do things like a motor control. All right, so you see people like OpenROV, they're building those underwater exploration submarines, and they're actually hooking up webcams and streaming video back over. That's a little bit more advanced. So I just wanted to show you like the really quick, simple stuff that you can do. And this is just straight HTML and JavaScript. And I'll go through the code, but I want to get through the demos first. The last one of these is Processing.js. So Processing.js is an open source JavaScript library. So all the other ones were, so first we were just manipulating content within the page, and then we were doing some graphing. This is a general purpose visualization language entirely in JavaScript, and it's extremely easy to just start plugging in physical interactions, right? So if I press the button, you see the blue ball turns red. If I move the slider up, the ball goes up. If I move the slider down, the ball goes down. So after this, I'll show you the code, how it's actually put together. And if you're brand new to JavaScript, there's also this wonderful tool called Google Blockly. And so you can actually generate the JavaScript you want to do these physical interactions using Blockly. So say every 1 second, I wanted to go and read my one of my analog input pins, right? So this limits it down to the different pins that have analog to digital converters on, so I don't have to worry about that. So I could set that to the analog input pin that I want. And then let's say I want to actually write that back out to a, write. I want to write that back out to a pulse width modulator and control the brightness of an LED, let's say. So you can see here it's taking the analog read value and putting it in value. So I just grab the variable that I want and drag and drop that in here. And now I click Generate JavaScript, and now I have valid JavaScript code. So if I'm brand new to programming and all these syntaxes with the curly braces and parentheses or something that's really complicated for me, I could always use one of these graphical programming languages to get started. The last thing I want to show you is something that Google announced just last week, which is a thing called Google Coder. So Google Coder is actually very, very easy to move on to the BeagleBone Black. This took me about I think an hour to actually go and move this over. And what it is it's an environment to help kids create web pages, right? So it's something that's if you're creating some sort of web pages for the first time, it gives you an environment here where it shows the live web page, but I can click and actually see the HTML that's generating that web page along with some examples, and also get a live preview. So if I want to say hello to Maker Faire, I can go ahead and save that. And again, this is something running on a web server that's living on the board itself, right? So I can go and put this off anywhere on the network, and now I've got a tool for going and creating my own web pages and learning how to do those things. And from the stuff we've shown you earlier, right? You can start adding in those physical interactions in here and coding up things in HTML and JavaScript. I actually want to pause for any quick questions just to make sure that you guys are kind of getting a feel for what's going on here, right? So we're creating web pages here and running them directly off the board, and then we're able to actually do physical interaction. So does that make sense to everybody? Any quick questions about that? Can I show you some code? All right. Oh.
So is Blockly just generating JavaScript then?
So the question is Blockly just generating JavaScript? Yes, that's all I have Blockly doing here. It just generates valid JavaScript code. You can easily just run it right there too. Because all of this is just running on the web page itself. Yes, in the back. The question was, they noticed they had BoneScript as an option on the Google Coder, or I'm sorry, the Google Blockly page. Was that something they did? No, that's something I did. So I actually created all the BoneScript blocks inside of Blockly. But I'm sharing. It's all open source, so everybody can benefit. All right, let me show you what the code looks like for this first example. So just about any time you construct a web page and you need to use some sort of JavaScript library, you've got these script tags. So if you've seen HTML, you're familiar with tags. So the script tag tells the browser where to go get the JavaScript code. And here I'm just using the JavaScript library and the BoneScript library, right? So the jQuery library. So the jQuery library is the one that allows me to manipulate the page dynamically, and then the BoneScript library is the one that allows me to physically interact with the board. I've placed a couple of items on the page here to represent what is the button status and what is the slider status. So I have something where I want to be placing that information to be updated. And then I need to tell the JavaScript in the browser where to go and connect with that board. Because I've got it physically wired up, and the way that the BeagleBone ships is it always serves up the address 192.168.7.2 when it's connected up over USB. But I could easily replace that whatever the name of the board is. The board actually will broadcast its name on a network using a protocol called a Vahi or Bonjour or MDNS. So I could put in something like a BeagleBone.local so it'd find it on my local wireless LAN. But this is simple for this environment. And once it's made that connection, it's going to run that code. So you need to now reference. You need a variable in order to reference the BoneScript functions. We do that by doing this var b equals require BoneScript. So that variable b now has all of my BoneScript functions associated with it. I've got my variables for the two things I want to print on the screen. These are the pins where everything's wired up. So in BoneScript, everything is referred to by the pin header names. So I don't have to go back and refer to any other documentation in order to read the code. So I'll print it on the silk screen as a P8 and a P9. And those are the pins where I've got things wired up. So in JavaScript, this is a function call. And JavaScript has this thing where it's a thing called a callback, which is actually really nice for doing physical computing, because what it does for you is when there's an event, like a timer runs out, a function can run for you. So you're able to pass functions to other functions so that when something happens, you can respond to it by having it call that function. In this case, when I get the data back from reading the status of the button, I would like it to go and update that on the page. And this right here, that's the code that's actually dynamically updating the status of the button on the page. And that's essentially all you need. And then I just want to run that function again. So I'm going to say in 100 milliseconds, or go ahead and run that function to read the button again. And then preview here in the environment is just going to make me browse to this HTML file that I've saved. And you can see that's all the code that I need in order to dynamically respond to the button presses. I know I took a bit of a jump there, but I want to back up 1 second again and just say what we're seeing right here is a web page that's being served up by the board. Even here, this is called a Cloud9 IDE. a lot of folks get confused because there's a company that says that serves the Cloud9 IDE on the web. So that you can develop your code anywhere. And this is using the same code because it's open source. But you don't need to go sign up for Cloud9 or do anything like that in order to use this. It's actually served up by the board itself using the open source project. Now, if I wanted to synchronize it up to the cloud, I could go and join the Cloud9 service and synchronize that between them. But here, it's just running directly on the board. I didn't have to go and install anything. I just literally plugged it into the computer, it serves up the IP address, and it's ready to go. And if I needed any drivers, they're actually served up from the board as well. So I've never had to actually go onto the web in order to do any of this. And it's something that David pointed out earlier is in addition to the IDE that's being served up on the board is documentation for those individual functions. So if you see here, I'm trying to read the button. This is documentation being served up on the board from how to do that digital read command. So if you see, if I run that, you can see I can read the value as 1. That's because my button has a pull up, so its default state is 1. If I press and hold the button and I run the same thing, you see the value 0. So this is all, again, something that just ships directly with the board. And I've just added here on the jQuery library so I can create those dynamic pages. The Flot demo looks extremely similar, except I've got some extra CSS or cascading style sheet stuff to set up what I want the format of that graph to be. And you can see I'm also here reading in an additional library now, which is that Flot library. And this is just an open source project. There's lots of good documentation on Flot on the web. I just want to kind of show you some of these. And here, again, just setting up the web page and the magic of reading. The slider happens right here when I do this B analog read. That's what reads the button, the position of the slider, so I can get that analog value back, and then I'm simply updating that data in the data on Flot. So if we just preview this, so that's the code that's giving me this graph. And of course, I can change all sorts of things about it. I can change the rate if I want to read it slower. I can change the time between I read and update the samples in the graph. So similar here for processing. Like the others, I'm reading in the processing library. This one's got a really big community around it of people developing stuff with processing.js. They have a really nice website where you can actually dynamically create some processing.js code and see how it updates live. So you can go and create all your visualizations, and then later just go back in and add the Bone script calls. That's all the things like the analog read and the digital read in order to take your physical world interactions and start putting those up there. There are some other great frameworks. One I'd recommend is Space Brew. I didn't include my Space Brew demo because I can't get out to the internet. So if you were able to get to the internet, there's a Space Brew, and Zively has a JavaScript API as well. So you can take all this data everything I'm showing you is being served up and run right here, and put that all out onto the web and share it with other people. So people have done some really fantastic projects where they've taken Geiger counters and connected them up, and then have shipped that data back up into the Zively service. And then they can actually track like radioactive activity, so they know what the hotspots are. Actually, yeah. So why don't we go ahead and what's your question? The question is there any type of encryption? So certainly it's possible to run encryption. Everything that I'm demoing is done, most of what I'm doing here is done without encryption. I will add in SSL support for Bone script. It's not in there right now, so SSL provides a secure connection between things. There's nothing preventing you from creating secure connections. It's just that my goal has been try to make it accessible and easy first, and then add security later. Other questions? Are you allowed to step over programs? Yes. So a nice thing is I'm using the Google Chrome browser, and the things that I'm seeing in here, when I go into preview, there's actually a debugger built in to the Chrome browser. So if I go under Tools and the JavaScript console, you can see any messages that it's printing out, and I can also set breakpoints directly in the code. So if I want, I can set a breakpoint here every time I get to the analog read. Let's actually get back where we've got the data. So here I can go and run. I put the breakpoint in a bad place. Anyway, the answer is yes. So I just need to put a breakpoint in the right place, but it actually gives you the ability to single step over functions and everything directly in the browser, and that's not something that's coming from us. That's something that's directly in the Chrome browser. The question is do we have a C API? The answer is yes. It does not ship with the board, though. Right now, there is a nice C API project that gives you some of the higher level abstractions to make it look like Arduino sketches. That's a thing it's called user space Arduino. It's something that's actually generic to Linux, right? Because we're using the Linux abstractions for the GPIO interfaces, for the ADD conversion, pulse width modulators, and all that. So it's actually a generic project that works with other Linux systems, but it's a user space Arduino. So it's a project you can download. What's the other question? So that the comment is about processing JS being actually derived from the legacy of processing, which is actually the language that. So if the kind of the lineage is processing JS came from processing, but at the side of that, Arduino actually came from wiring, and wiring came from processing. So they have a very close development history, a development lineage. Yes, so the idea, the processing JS environment will look very familiar to a lot of Arduino developers because they have a common legacy. Absolutely. Other questions? Can you do real-time stuff in Socket.io? Yes and no. I would not ever call it hard real-time. Anytime you're doing TCP connections, TCP is a non-real-time protocol. You need to get into UDP. Socket.io has different fallbacks. We're getting pretty deep now, but Socket.io has different fallbacks that it can go into. It's fairly reliable, but I would. There's ways to there are ways to keep the sockets open. So it will try to use WebSockets. But that's still, even though it's high performant, it's still a TCP protocol, and so you could potentially miss real time. There's not an obvious fallout. You can design a real-time system, but most things in the web are not really meant to be real-time. I mean, I think that when you look at something like my Flot demo, right, it shows fairly practically that that you can have very responsive web interfaces using this. Will it ever potentially miss a sample? Absolutely. So you have cache, you have a garbage collection that goes on in the web page and stuff. So this is not safe for hard real time. The board itself, however, does have some hard real-time features. In addition to running Linux, it actually has two 32-bit microcontrollers that are running at 200 megahertz. And those are actually just completely available for you to put real-time tasks on. And you'll see some really fantastic demos even here. If you see the little spinning globe with the LEDs on it, That's using a BeagleBone Black, and they're using those microcontrollers to shove the data out to those LEDs. You'll also see if you go upstairs in the museum, there's a very large architect LED sculpture that's using BeagleBone Black to feed all the data to those LEDs, and that is doing stuff in real time. But in general, if you want to do stuff in real time, move it off the Linux processor. You can patch Linux to do real time, but it's a challenge. So I've got just a couple more minutes for questions. All right, fantastic. I really appreciate your time. We are selling the boards here in the Maker Shed, so they're $45. And the stuff that I'm showing you, again, you plug in the USB cable. There's the manual is all of about this big of a business card. Please do read it. About a third of our questions coming up on the mailing list are ones that if somebody actually just read the URL and actually went to the website and looked at it, their questions would be answered. The BeagleBone is true open source hardware. People can take it and modify the design, do cool things. It's also a modern processor that you can run Ubuntu, Android, right? So I mean, I show you just like the JavaScript stuff that I'm looking for, making really easy for people. But if you want to do advanced projects, you already have an idea of what you want to do with the Linux computer. It's already there. I mean, there are people doing it, and you just have to look. And so I do hope you check it out. Again, it's BeagleBone Black. Thank you very much.